Sir, am I audible?
Yes,
So that I could start.
Yes, ma'am. Perfectly
Yes.
audible.
Okay. Haratvam sansaram drutataram asaram surapate haratvam papanam vitati muparasaram jadavapate aho dinanatham vihitam achalam nischita padam Jagannath Swami Nayana Pathagami Bhavatumi. Namaskar and good evening one and all present over here. Respected Principal, Vice Principal, Chief Guest, Head of the Departments, participants, organizing committee members, students, a warm welcome to everyone. I, Professor Anurekha Naik, welcome you all to the national webinar on Design and Fabrication of Power Electronics Converters for High Power Industrial Drives, DFPID 2K21, organized jointly by Department of EE, EEE and ENTC, DRIEMS Autonomous Engineering College. Power electronics is the study of electronic circuits used to convert and control the flow of electrical power. Power electronics has been a tremendous growth in recent times, and almost all the applications today use power electronic devices in some or other form. Hence, it becomes essential to study the advantages of the devices, which makes it so popular. That is why this webinar has been organized to gather more knowledge on this area. So thank you every one of you for being here with us today. Now we will offer prayer to Lord Jagannath.
नीलाद्रौ शङ्खमध्ये शतदलकमले रत्नसिंहासनस्थम् सर्वालङ्कारयुक्तं नवघनरुचिरं संयुक्तं चाग्रजेन भद्राया वामपार्श्वे रथचरणयुतं ब्रह्मरुद्रेन्द्रवन्द्यं देवानां शारमीशं स्वजनपरिवृतं ब्रह्मदारु स्मरामि ब्रह्मदारु स्मरामि ब्रह्मदारु स्मरामि.
With the blessings of Almighty God, let us proceed further with e-lighting of the lamp of prosperity. Thank you, everyone. Now, I would like to invite Dr. Pratap Chandra Pradhan, convener to this webinar, to deliver the welcome address.
Am I audible? Okay. Hare Krishna. Good evening to all of you. Honorable Chairman, DRIEMS Group of Institution, Srijukta Pramod Chandra Raj. Pro-Chairman, DRIEMS Group of Institution, Engineer Durga Prasad Raj. Director Admin, DRIEMS Group of Institution, Srijukta Balaram Kaur. Director, DRIEMS Group of Institution, Professor Loknath Behera. Assistant Director, DRIEMS Group of Institution, Engineer Sudhanshu Bhushankar. Principal, Professor Dr. Rajendra Kumar Das. Today, guest and speaker, Professor Dr. Ranjan Kumar Behera, Associate Professor, Department of Electrical Engineering, IIT Patna. Vice Principal, Professor Dr. Ranjan Samal. Vice Principal, A&R, Professor Dr. Alok Ranjan Biswal. Dean Academic and HOD ENTC, Professor Dr. Jivananand Behera. Dean Student Welfare, Professor Dr. Lina Patnaik. Dean R&D, Professor Dr. Sachikanta Das. Convener of this national webinar, Professor Sushant Kumar Sethi. HODs,
Good evening, sir.
Professors, my dear colleagues, students and delegates. I, Dr. Pratap Chandra Pradhan, HOD, Department of Electrical and Electronics Engineering and convener, welcome you all to this national webinar on design and fabrication of power electronics converter for high power industrial drives, organized by Department of EE, EEE and ENTC in association with Green Energy Club. This webinar is meant to disseminate the knowledge in the area of design and fabrication of converter for industrial drive. Power electronics have been fully introduced in industry in applications such as power supplies, converters, inverters, battery chargers, variable speed motors. By studying the effect and the adoption of electronics power system to industrial processes. Power electronics converter have been developed for several years with many types of applications. One of the major applications in the drives of electrical machines mainly used in the beginning for industrial applications. Today's speaker, sir, is going to discuss more about design of converters. I am sure that all the participants of this webinar will be benefited. I would like to welcome you, sir, to DRIEMS and to this webinar. Once again, I would like to welcome you all to this program. Thank you all, and we look forward to an extremely productive discussion. May Lord Krishna bless you all. Thank you.
Thank you, sir, for giving the insight of the webinar. Now, I would like to invite Dr. Alok Ranjan Biswal, Vice Principal, Academic and Research, to share his views on this webinar. Sir, please.
Thank you, ma'am. Ma'am, I am audible? Am I audible, ma'am?
Yes, sir, you are audible.
Okay.
Yes, sir, yes, sir.
Very good evening to one and all present over here, and welcome to today's webinar hosted by Electrical Engineering, Electrical and Electronics Engineering, and Electronics and Telecommunication Engineering Department of DRIEMS Autonomous Engineering College. Hopefully, you all are doing well. Respected Professor Dr. R.K. Behera, Chief Speaker of today's program. Respected Professor Dr. R.K. Das, Principal, DRIEMS Autonomous Engineering College. Professor Dr. N.R. Samal, Head of the Electrical Engineering Department from Vice Principal Coordination. Professor Dr. P.C. Pradhan, Head of the Electrical and Electronics Engineering Department. Professor Dr. J. Mehna, Head of the Electronics and Telecommunication Engineering Department from Dean Academics. Conveners, organizing committee members, faculty members, staffs, dignified and respected participants, and my beloved students. First of all, I am here to give my profound thanks to Dr. R.K. Behera for giving his valuable time for us on today's program. Thank you so much, sir. It's a privilege to hear from you. The day-to-day use of electrical, mechanical, electronics, gadgets or equipments nowadays significantly affect our livelihood. The industrialization of such products affect not only to the economy, but also to the sustainable growth of any country instead. Researches have been carried out across the globe, and every day some new things evolve around us. In order to keep in pace and to be familiar with such gigantic development, it's needed to have some sound knowledge of such things. Organizing seminars, webinars, workshops, expert talks, and many more are really a great initiative nowadays for this, so as to meet, to share, and to discuss on various happenings around us. With this, I'm extremely thankful to all the core committee members of respective departments for arranging such webinar and provide a chance to meet such experienced expertise on this field. My heartiest thanks to all the core members of the management and all faculty members and staffs of the Electrical Engineering Department, Electrical and Electronics Engineering Department, and Electronics and Telecommunication Engineering Department for organizing such beneficial program during these hard days. I hope this program will immensely beneficial to all. Thank you all. Stay safe and healthy. Thank you. Over to you, ma'am.
Thank you, sir. Now we have with us our Vice Principal Coordination, cum Principal in Charge, Professor Dr. Ranjan Samal. I request sir to share his ideas with us. So please.
Am I audible, ma'am?
Yes, sir. Yes, sir. You're audible.
Okay. A very good evening to all of you. Honorable Chief Patrons of the webinar, Srijukta Pramod Chandra Rath, Chairperson, DRIEMS Group of Institutions, Engineer Durga Prasad Rath, Pro Chairperson, DRIEMS Group of Institutions, the Patrons, Srijukta Balram Kaur, Director Administration, Professor Dr. Behera, Director A&C, Engineer S.B. Kaur, Assistant Director A&A, the Chairperson of the program, Dr. Rajendra Kumar Das, Principal, DRIEMS Autonomous Engineering College. He is absent now due to some emergency work. Dean, Student Welfare, Dr. Lina Patnaik. Dean, Academic, Dr. Jivanananda Mehna. All HODs, professors, faculties from DRIEMS Autonomous Engineering College. Esteemed delegates from the different organizations, institutions present over here, and my dear students. On behalf of DRIEMS Degree Autonomous Engineering College, a hearty welcome to all of you to this webinar, Design and Fabrication of Power Electronics Converters for High Power Industrial Drives. First of all, we must appreciate our speaker, Dr. Ranjan Kumar Behera, Associate Professor, IIT Patna. In spite of his busy schedule, he is with us to discuss about this advanced topic. Before that, we must have the simple knowledge about electronics and power electronics. Actually, what is the difference between electronics and power electronics? Electronics deals with transmission of information signals in the form of electrical energy, whereas power electronics deals with transmission of electrical energy itself. Then what is the role of power electronics? Actually, there are three major roles of the basic function of power electronics. Number one is your power conversion, which is very much important. Conversion of AC to DC, DC to AC, AC to AC, and DC to DC. The number two is power conditioning. What is conditioning? What is power conditioning? Actually, it removes the distortion, harmonics, voltage, sag, or over voltage, up and down, etc. And finally, the frequency and high speed control. Hence, in broad sense, we can define power electronics is the application of solid state electronics to control and conversion of electrical power. Here, our speaker will discuss on this advanced topic in how the converters are used in high power industrial drives. I hope this will be very much helpful for us. With a good hope, let us proceed to our webinar. Thank you very much.
Thank you, sir. Sir, just now our principal sir has joined.
Anyway, he is on leave. You may
Sir has
join.
joined actually. Yes.
Hmm.
Okay. Thank you so much, sir.
Sir, good evening.
Now I am profoundly delighted to take an opportunity to introduce our chief guest, Dr. Ranjan Kumar Behera. Dr. Behera completed his BE in Electrical Engineering from NIT Rourkela, MTech and PhD from IIT Kanpur. He worked as a visiting scholar in the Energy System Research Center, Tennessee Technological University, USA, and also as a visiting scholar collaborator at ECE Department, University of Pretoria, South Africa during 2016. He got several national and international awards such as Young Scientist Award in Engineering Sciences from DST Government of India in 2001 and selected as the featured engineer of the globe in 2015 and USA and the Vaskar Advanced Solar Energy Award Indo-US Science and Technology Forum in 2014. He published 134 number of research articles in different national and international journals and conference proceedings. His current research interests include power electronics, high power motor drives, smart grid, and IoT applications. He is co-authored to a book entitled Power Electronics, Drives, and Advanced Applications in 2020. Sir is currently serving in IIT Patna. Now, I would like to request Dr. Ranjan Kumar Behera to enlighten us with his knowledge on this topic. So, please.
Thank you very much, madam.
Thank you, sir.
Although I am not qualified like that, just I am also a student only. So I learn in every step of my life. And I thanks to the Dream Group of institution as well as the management and especially to the professors, Professor Sushant Sethi for inviting me. And especially when I get an invitation from because in this last 1 year I have given nearly 176 lectures all over India, all over the world. And when I call for Odisha, my heart actually is in Odisha. And every day I say that I must go back to Odisha, I must go back to Odisha. But anyway, wherever by Lord's wish, I'm here. So thank you so much. So today I will give a topic where generally we never discuss this one. So this topic, because it is a very interesting topic for me, because my students also, I tell them to fabricate everything by your own hand. Then only a complete engineering status you can give to a student. If a student do not know how to fabricate a simple hardware circuit or something, it is very difficult for us to tell him he's an engineer. So when I give one very beautiful story that when I was working in Tennessee Technological University with Professor Gao in the Energy System Research Center, and first time I developed a inverter which run an induction motor, and everybody became so excited that the whole lab came there to see that how the induction motor is moving with our manufactured inverter. Till that time, nobody was designed. And then subsequently, we designed a double fed induction motor based a 500 kilowatt DFID based wind turbine, and that was the second, and that is why they give me that every year in summer, Dr. Behera, you can spend at least 2 months here in the Tennessee Technological University. So every summer, generally I travel to USA just for this hardware training to give the students, as well as many faculties also attend. So this also I will very happy to share all of you that in my lab, our students have developed a first time in the whole over the world that multi-phase matrix converter, which is first time we just developed. We have not tested yet, but we have developed this one. And I also invite everyone, those who are doing PhD, those who are students, they want to work, and those faculty, they want to do some hardware, they can come to our lab, and it is extended for everyone. And all over India, many people, they come here and take the advantage, and no need to put our name. You can publish with your own guide, but you are most welcome. And I always invite, and from CT2 students are working, they are developing hardware here, and they have completed from VIT, from NIT, Agartala, from NIT, Patna, from NIT Jamshedpur. Many people, they come for doing research here. We have every facility. So because we spend nearly more than at least 50 crores rupees to develop the labs. So I invite everyone to do this before going to this one. So already Madam told the journey of my life at a different phase. And we also develop many, at least we in the solar field and wind turbine field, we are very good, especially in Bihar. We put around more than 15 projects all over Bihar in the Araria district, Punya district, as well as in Vaishali district, solar irrigation starting. And last project we did 1 megawatt solar plant planning design as well as installation at Port Blair Air Force Station in Port Blair, 1 megawatt solar energy. So we developed many the projects. So there are many projects which we developed in the laboratory here, and every design, every single bit design our student does, and we implement and perfectly. I think this is so. This is my last book, which so today, if you see in India, high power converter design is a great challenge. Like I visited last year to Solar Energy Institute, Gurgaon. So in that institute, because I am an advisory board to that institute, so when I visited, I asked, so how, what is the maximum rated converter you can test here? They told that only 10 kilowatt power converter they could able to test, grid integrated converters. Okay, so I became astonished that in India till today we do not have a facility to test 100 kVA converter system or a power electronic circuit. It is really, and the it was really I was just feeling very unhappy. Then I gave them proposal that in our lab we develop up to 75 kVA design, and you can come and test it. So we develop a testing facility here for the grid integrated inverters up to 100, now up to 100 kVA we have developed here in the lab. So if you see the power electronics today, in the previous day, if you see if you want to convert from AC to DC, you have to bring a AC generator, then AC motor, run to a DC generator. DC generator will give you DC. So big structure today, a power electronics with a small device could able to convert that 1/10 of kVA. For example, you see a MOSFET, it is just a small piece. When this MOSFET you are connecting, then if the MOSFET current rating is 55 ampere and voltage rating is 10 ampere, the power electronics rating is 500 watt. This is the beauty of this power electronics. That is why today everywhere without power electronics you cannot do anything. That's why India government has launched National Mission for Power Electronics Research, NAMPET and IIT Patna. They are getting lot of support from NAMPET. I must thank to NAMPET, Government of India, for providing us at least 1 crores of rupees for developing the power electronics and giving A-rated A-rated lab to our lab, that the lab which developed the complete electric vehicle. So then the power electronics came. Now the fourth phase also came, and as the machine learning, artificial intelligence also coming into power grid. So it is coming. So it is a multidisciplinary. You need everything actually, because power electronics, when you design the heat sink, you need thermal engineering. When you want to design the protection circuit or the control circuit, you need electronics and the communication, as well as our what you call digital electronics. Everything is required. When you go to power system, you require power system protection, everything. And when you analyze the electromagnetic, like EMI, electromagnetic interference, when you design the big converters, that time it comes. So that time the telecommunication signal processing, everything comes. And to control everything, you require a high performance computer. I remember when we used to do in our initial days of research, we used to bring a computer, we will open, we will see that inside the computer, if you open, there will be PCI ISA slot, the Princeton architecture slot. Nowadays it is not there. Not only ISA, international standard, that architecture is there, where you can insert your data acquisition card. So we used to open it, and you need to know the computer engineer as well as the power electronics, VLSI, microelectronics, everything comes to this picture. That's why power electronics is the complete subject and very difficult for people to actually develop the complete unit. So if you see, there are a lot of power electronics. I remember when I was in University of uh, this in the Alaska University, they have designed long back. So they will have a, because in the night time the whole house will cover with snow. You cannot even open the door. As soon as you open the door with the inside, you have to cut the ice. Then only you can come out from that place. So like that, whenever the people used to have a portable cutter, they will cut and they will make it the road. So these are the different kind of high power drives. So before going to the design, I must say, you see the complete drives of a hot strip mill. If you go to steel plant, you will find there are 1 megawatt drive. You can see these two big shafts. This 1 megawatt drives, they both are adjustable, okay, can go up and down, and they all will press. When a big slab of iron will come from the hot slab, and then it will come through this all the cascaded DC motors, which I have shown here. They will roll it actually, and then there will be pressing which will make a strip up from that slab. So if you see, these are required the very robust controller with the power converter, which is operating from 0 degree up to 67, 80 degree centigrade. And that is what, when I visited my one of my friend who is working in John Deere in North Dakota, I visited in the USA to him, and they have a testing chamber, because they are designing for Alaska, England, Canada, all the northern region. So they test it from minus to plus. And in India, we also need to test it, because nowadays the temperature goes very extremely high and low also. So you, whatever your watch is working here, if you go to Alaska, this watch will not work properly because of that environment temperature difference. So then there are a lot of engine that by our first development of multi-level converter, multi-phase drive
PPT
was
is not visible, sir. Sorry.
uh,
PPT is not visible, sir.
now is it visible?
No, no,
This is
sir.
motor in
Clearly
industry.
visible.
No, it is
No.
visible, sir. It is
Sir,
visible.
clearly visible. Clearly visible, sir.
Okay, okay.
Clearly visible. Your problem, sir.
Now you see, is it visible AC motors?
Yes, sir. Visible, sir.
Okay, thank you so much. So our first project was we got a project in the under the Young Scientist Award for the ship propulsion engine design. If you see this propulsion engine, because this propulsion engine is designed, you can see that this is the propulsion, ship propulsion, and we designed this ship propulsion engine first time in our laboratory by using 5-phase machine, because 5-phase machine, even if one phase is out, then with 4 phase you can run this complete unit. And I remember when I visited to Cape Town in South Africa. In South Africa is in Cape Town is a small, very beautiful place, and in that there are at least six big the manufacturers of the ship are there. So when I visited the lab, I asked them what type of still that time they were using only the three-phase machine and with backup machine because it every structure is modular, so they designed with three-phase, but we designed here with a 5-phase machine. And we also developed a technology for the textile mill where the synchronous machines are used, because the textile mill you require a very constant speed machine. If little bit there will be vibration due to the fluctuation of your voltage, the complete paper quality will destroy. That is why if you see the paper drive, they are using very robust synchronous motors for that. So when I was working with the this JK paper mill, so with that time we gave this one, but it was for not for JK paper mill. So the adjustable speed drive is main element, and this like you are driving a scooter, you are seeing an obstacle in your front. So what you do, you slow down your scooter. So when you slow down your scooter, automatically your eyes are the reference. They give the reference, yes, you must drive down. Then your brain process, and when brain process, then neural cortex, all those things, they gather information out of thousands of combination and permutation, one proper result will give to control that one. We have to control. So that is the complete control unit. Exactly in the power also we do exactly like that, power electronics. So today our main important topic is power electronics converter design. Okay. So there are different converters like voltage source inverters, current source inverters, cycloconverters. They are used, and this when you use that converter need to be controlled. For example, in Indian Railway, our first project, because Indian Railway, the first project was started in 1994, where GTO gate ton of thyristor based converter were designed, because it is a 6,000 HP electric locomotive. It was in 1994. And then in phase two, the government of India, they have changed this one. And I was working one of its project. So GTO based power converter, which and IGBT based auxiliary converter. If you go inside train engine, if you go to specially to Chittaranjan, as I am a consultant to railway, I generally move to Chittaranjan always. When the converter come, we do testing other thing before installation inside the rail engine. So initially in the 2001, they developed the GTO based power converter and IGBT. All these converters we purchased from Alstom, GE, or Toshiba or Toshiba and Hitachi. These are the companies, they supplies. We never developed here. That's why in phase 3, Mr. Ramvilas Paswan, who was the minister, he gave this project to IIT Kanpur to develop IGBT based power converter and both auxiliary converter. First time, because IGBT became very good tool for controlling as well as for designing. So if you see this, there are GTO based converter based. This is electrical multiple unit, and Millennium Rake, which is in the Western Railway Bhopal. So they have developed this one and the based and then high speed multiple EMU was designed, and then this, if you see a railway engine, you have a converter rating of 70 kVA and 115 kVA. So they have given this specification to the company, they design and give us, and we use that one. If you see this one, between this packet, you need to fix everything of your converter, inverter, controller, and filter circuit, battery circuit, all the element. So then you have a outside, you have a bushing. You can see here two bushings are there. This bushing are fixed because the railway that is having lot of vibration. Under that vibration, this converter should not have a loose contact because complete unit is so large. If you go inside, you will see that there are a lot of component in the railway. So drives is the heart of the locomotive, and most of all AC drives you used in Indian Railway are imported. First AC locomotive drive was purchased from the Australia, and that was running as a Shatabdi train between Lucknow and Delhi. Lucknow Delhi Shatabdi is the first locomotive which we purchased from Australia. Complete railway, complete whole railway, including all the bogies, everything purchased from Australia. So after that, India government thought that why don't we develop the AC drives and for Indian Railway. So if you see the AC traction motor before going into design, you can see that there is a main rectifier. Today we do not use this rectifier circuit. Okay. And you can see that from the overhead line 25 kV, you have a pantograph. Pantograph come to the below, there is a horizontal transformer. You must have seen vertical transformers in the substation, but you haven't, I don't think that you have seen the, if you go to railway, you will see that the horizontal transformers. So this is a horizontal transformer, then a rectifier, then inverters, they drive these big motors, and there are auxiliary also converters we supply for the battery charging, compressors, and also ACs. All these things are there, blowers, everything, and coolant, because if you see big fans are running and they are controlled from this auxiliary converter in a this. I remember in Indian Railway we have only a simple control structure, the speed, high speed, medium speed, and low speed, and a breaker and a plugging in it. Whereas if you go to European country where I was working with TJ, I was traveling with TGV from Paris to Madrid in Spain, and 550 miles per hour that train travels. So as a part of this project, I was deployed there to test this. If you see their engine, front engine, you will find that it is exactly like your aeroplane, this panel. Exactly all wheel dynamic and ripple, the wheel parameter, everything you can see in that panel. And nowadays, if you go to Chittaranjan, we are also started applying this. We have now a panel where the driver can see everything. So when we see these big converters, and when we see this power converter are IGBT based, then this was given to us to develop. And group 2 number traction motor per inverter. One inverter will drive two traction motor, and it should operate in four quadrant operation, means forward motoring, reverse motoring, forward braking, reverse braking. These four things are very important in this. So like that we need to design. So what is the challenge today in India? In India is it is 4.5 megawatt drive, and you need to design high power switching converter design, and you must be very compact to only install within the traction motor, and real time digital controller, because little bit mismatch can derail the whole complete rail engine. So that is why very important is the real time control. And second, third thing is integration and deployment in the actual locomotive. So that was given to us the task. So let us start. There are a lot of power electronics component. One is the switching device selection. How to select the switching device. For example, you have given 1.5 kilowatt device rating. Means what do you mean by 1.5 kilowatt? That means it should have 1.5 sorry, 1.5 kV voltage blocking, means reverse voltage. They must block this much voltage. So then we have a power IGBT, whether you will select, you will select MOSFET or power IGBT, GTO, thyristor. There are so many devices. How you will take. And second one, auxiliary designs like capacitor, inductor, what kind of bus bar structure, everything you need to think. Third thing is gate driver and board selection design. Fourth thing is protection, because without protection you cannot install. So this is the specific approach, that first you put the rating, and then find out the parameter, current, voltage, all these things. Then device selection, you can see there is our picture, and you can see every component we developed in the laboratory. From the Teflon sheet, the insulation rods are made. You can see from a bronze, from a simple copper, you designed the connecting rods and complete the hardware design. The components are shown you here, and it is from the drilling to everything we design from our lab. And these are the IGBT. You can see that MOSFETs. And from here, the data sheet is given. And from the data sheet, you can find out what is the characteristics of this MOSFET. Then we have similarly IGBT. So we have dual module IGBT. Any IGBT you purchase, like here semicron. This IGBT, two IGBT in one module. And this module, after studying the your data sheet, one must read data sheet before this. That is why I always tell my BTech students also, I will give them a capacitor, I will give a data sheet, I will ask them what is the input capacitance, what is the output capacitance, and what is the stray capacitance in this. So they will speak me very nicely actually. That is how I take this one IGBT module. I will take them. You cut this IGBT module and show how the microelectronic circuits are designed and where it is. And there are a lot of liquids, why these liquids are provided. So they learn many things in the class itself, and I give them. They take it 1-2 days they study, and I give the data sheet. I tell what are these parameter, why it is given, what is the safe operating area. They try to understand this. Even though they look at this, they learn many things practically. That is what in power electronics, the theoretical knowledge is very less important, where practical knowledge is more. That is why when power electronics, we should take the pulse transformer and all these circuits, they should see in the class. Then they will remember very quickly. That is what the power electronic circuit. So then designing a small power supply. You see here, our students, they have designed the power supply of 220 volt to 18 volt, and for 15 volt plus or minus 15 volt power supply they have designed. And they have designed this 15 volt power supply. Why? Because there are optocouplers, there are isolators, everything need to be, there are op-amps which you want to drive. All these things are connected here. You can see this is a PCB design also they have given, and PCB design also very beautifully they design it in the lab only, and then we fabricate in Bangalore, because we do not have fabrication facility here, but we fabricate in Bangalore, or they by etching they could be able to do also sometime. So this is the driver board, means when you have a switch circuit, you need to drive that one. Okay. So that driving force is your, for example, if you are going to, you want to study, what is the driving force? Driving force is your inspiration. Oh, I must study. My father sent me here. Let me study for this. That is your driving force. Similarly, any device, there is a driving force, is this driver board which runs, which controls. When you on, chalo. If you not, for example, you have a tape, you just open the tape, then water will come, and close the tape. That is what is the controller. Controller is your tape. So exactly here also, exactly this semicron is the controller. And this Skyper board, you can see that we have connected in the below. You can see this Skyper board are available today, but during our time it was not available. We need to design this gate driver circuit. So the IGBT must be controlled by the gate driver circuit. And this is our, you can see this is a inverter circuit, single phase H bridge inverter. I think all of you must have known. And this driver circuit is nothing but this semicron, this green one circuit. You can see here, these are the driver circuit. And these are the different power supply circuit. You can see here the power supply. And then how we get signal? We get from the computer, we control this Opal RT real-time simulator. From this, we get this pulses. So pulse you get 5 volt, okay? But this driver may be 15 volt. So when you are applying a 5 volt you are getting, you need to amplify that circuit. If you don't amplify, this IGBT not work. So you need to amplify according to data sheet given. It may be 15 volt, it may be 12 volt, it may be 18 volt. That way we need to design that one. That is why design aspect you need to take care of many things. And now you see here voltage transducer. That means this will measure our voltage. This LV25P will measure your voltage and give information to the data acquisition board, and they will give you your input voltage and you get the output voltage. So this is how the data acquisition system can recognize what is the voltage. Then after connecting the transducer, you need to test the transducer before connecting to this. That means you need to take, you apply some voltage, and what is the output voltage, you just measure, and then you plot it. If it is not fitted, if it is not linear, then you need to find out the equation where in your data acquisition card, in data acquisition system, where you take the data from the sensor to inside computer. Computer will read only the digital signal. You have a to D converter. In the after A to D converter, you receive this. So exactly if it is not matching the input to output relationship, then you need to develop a equation which can satisfy this particular thing and put into that data acquisition board. Then only you can measure the actual voltage. Then similarly, we have a current transducer. You can see here, the current transducer will measure the current input to your load or to your device. this current measurement also similarly you need to test it before connecting to the exact your drive system. So that is what the testing you must take carried out. And when the testing you see sometimes there are offset, sometimes there are also error. So there should be zero error, because little bit error can destabilize the complete drive, because you are not driving a small your pump in your house, you are turning on, that is small pump, you just turning on and it is run. Whereas these are the very high. As soon as I remember when I was working in General Electric Bangalore, my posting was in the Hong Kong. In the Hong Kong, we were planting, we were in G, we were installing around 1 megawatt wind turbine, and we put all the DFIG based. So it was around thing, and power converter, inverter, everything we installed there. And then just we came down, we came turbine started, there was some little fire. As soon as in 2 minutes, whole wind turbine burnt in the top only. So we do not know where is the what is the problem. So when again we went there to test that one around 150 feet above. So when we went there and was just tasting, we saw that in the gearbox there was a one gear which was broken half, and because of that gear, even though we have a lot of lubricant to give, but because of the broken gear, that create a little spark between two gears, and complete wind turbine burnt. And wind turbine, if you see, your centrifugal force must be stable, your torsional vibration must be stable, and your complete pole vibration because of this one needs to be stabilized. Then only a particular wind turbine can give you perfect power, or else it will create a very loud noise, and nearby people they will complain. Lot of things comes actually. So that is why this perfect measurement is very important when you are designing more than 100 kVA converters. Okay, so this is the protection circuit that nowadays the protections are available, but in our time we used to have a fuse protection, or we used to have a MOSFET protection circuit, a simple small like a solid state protection devices. So these are the relay and protection circuit which our students they have developed. And then there are many controllers. Nowadays we have a DSpace microlab controller, and also Opelati controller also we have. And we have the Texas Instrument, this processor, small controller we use in electric vehicle, and also FPGA controllers are available, and DSpace also available. So any controller anyone required in our lab, it is available. So fabrication of multi-level converter is very tough. I can remember I must have spoiled around 120 IGBT modules, Mitsubishi made IGBT modules. And my guide at last told Ranjan, you should leave PhD. I cannot give you more number because already you have spent one IGBT module was 5,000 rupees that time, and I burnt nearly 70 to 80 modules. And after that, I visited to ABB Switzerland, then Darmstadt University in Germany, and the Paris Polytechnic. Then I learned that how to design this high power converter system. And for 4 years, I just, for not 4 years, after 3 years, we could not able to. This is our first design, you can see. In the below, we used all the wiring for connecting these, this black color are the Mitsubishi made IGBT modules. And you can see there are first recovery diodes. These are the diodes. These diodes are first recovery diodes. And these modules are IGBT modules are here. Okay. So these modules, when we design and connect it like this wire, you can see in the top of this power converter, this is our triggering circuit. Means this is the control circuit, which is here. And these two module we designed initially. But what is the problem with this one? I can tell you. So when we are designing this one, you can see here the output. You can see this is our DSpace controller in this computer. And you can, but nowadays it is very easier to control. But in our time, we used to write 100-line program in C++. Then you compute it, and then you can give some lockout circuit. You can see here, this is a 3-level converter, but it looks like a 2-level converter. The output waveform or the output voltage is exactly like a 2-level converter. That is why you can see that although you design for a 3-level, because of electromagnetic interference, as well as there are some kind of noise within that, you are not able to get a sinusoidal current also. That is why we need to understand that how to design this perfect converter is the biggest deal today in India. And then when we fabricated, we designed with the bus bar system, and there are also a lot of problems. So I am just telling you, because of the wires, there are a lot of parasitic capacitance as well as a stray inductance effect. And that is what we should never use in the power circuit, a wire. Wire connection means like killing complete circuit. Then we designed, the first time we designed this multi-level converter by using the bus bar unit. You can see there are 7 bus. This is bus number 1, you can say. This is 2, this is 3, this is 4, this is 5, this is our 6, this is 7. So this is one bus which is connected. You can see this top bus. Top bus means here, this is a bus. Because there is no bushing, isolation, insulation, isolation there. So that is what bushing is connected directly. So 7-layer bus bar system we designed. And then this 7-layer bus, it is not that every bus will be connected everywhere, but it will, anyway, it is already time, I think. So I'll go very quickly. Anyway, if so, how much time I have? It is already 7:58.
Sir, continue, sir. Sir,
Okay.
sir, continue,
Okay.
continue, sir. No problem, sir. Sir.
Okay. Okay. Thank you.
Sir.
So there are 7 layers. You can see these are 7 layers. And this IGBT only used as a clamping diodes, neutral clamping diode. This is IGBT we use. That means if you can short the gate and emitter, then this can behave like a diode. So we use this as a diode, because to match the characteristics of diode and characteristics of IGBT, we use the same IGBT in that one. And that is how we assemble the multi-level converter in the laboratory, which is very, very, also in the IIT Bangalore, we got one award, that best innovative award for this one, the multi-layer bus bar design. And this you can see that each bus bar, you can see here we design bus bar number 1. You can see here, I have put this black color, means the upper bus, one bus is connected to this, only this black color. This one also connected. then this one is connected and the positive bus is connected. And the second bus, only it is connected this one and this one, this one and this one. Like that, if you see all these bus structure are connected like this, and this is RYB output connection. So this bus structure, after designing this one, then complete unit we design. For this, actually, Professor Ojo in TTU, in Tennessee Technological University, he will always tell Ranjan, you please present again. So whenever I go, I always present this one because this hardware design is perfectly designed. And till today, if you go to IIT Kanpur, you will find this is like a big monument in the laboratory. Everybody they come to see. And you can see here, we have a copper bar here. I have given copper bar. We are connecting them. So this way we developed this one, the complete unit, and then we design a complete component wise. For example, how to design this capacitor. This capacitor is a high power capacitor. Need to design considering the worst case. So that means the capacitor must be VDC maybe 680 volts. So we choose 800 volt capacitor. 800 volt. So like that, anybody can choose according to, we take little higher because the, then how to design the ripple in the capacitor also. So there are papers which we published long, those papers are available. When the capacitor voltage is like this, considering all ripple, we design like this. And then we, after that, we design the capacitor. So you see, I have given a problem here. The maximum line current is 15 kV, for a 15 kVA, okay. Converter is 36 ampere. Peak ripple current is 20 ampere at a frequency of 300 hertz. Assuming ripple, calculate minimum value of capacitor to be calculated. So if you calculate this one, so this is what we generally, I give to our students. They generally calculate, and when they bring and put a capacitor, it is not filtering the properly, then again they go and recalculate, again come, and like that they always enjoy this design, hardware design of this. So we used this what kind of IGBT. So IGBT, because we have a 36 ampere peak load, and this 36 ampere we use, and the temperature. Then we design thermal design. Thermal design, we took the help from the mechanical engineering people, and we designed, because like you design the your electrical circuit, thermal circuit also designed in that same way. And thermal circuit, when we design, we find out what is the size of your heat sink, which is, you can see here, we calculated heat sink size is, this is our heat sink size, is 215 into 300 into 75 mmq. And airflow rate, what kind of fan you require, that fan is 12 meter per second. It must have the blow the wind at 12 meter per second. So that way you can design this thermal controller, and there are this mathematics, I am not going. Then you have to find out what is the loss. You know thermal, then you find out the loss. And then you have these are the sensing circuit, like current sensor. This is a voltage sensor and current sensor. We measure in three phase, two current sensor, two current, because you know that IA plus IB plus IC is equal to 0. So if you measure two current, third current, you can easily just compute. IA is equal to minus of IB plus IC. Exactly. That is why two current sensors are used here. And this is the complete unit. You can see this is our driver circuit, and this is our, you can see that this is our heat sink here. It is, this is, and these are the capacitor DC link, and these are the each thyristor, each IGBT drive, 12 number of that. And this encoder come lockout circuit. Lockout means two switching signal, we give some clip or some for example, one switch is coming down like this square wave, other switch must start after some delay, or else if it will start from here, for example, if it will start at the same point at this point, so this will be short circuit of a DC link voltage. So to short, it will short circuit. That is why there is a time delay. That is called the dead time or lockout time. And there are many delay time also they call it. And then we developed this converter. You can see here very nicely. Here you can look. And by using a controller, you can control the converter. And this converter is controlled by this whole induction motor. And these are the, and our job is to design the converter control for the traction motor for Indian Railway, because it was the project by Indian Railway. You can see we have a input controller, input converter, which controls from input side to the DC link voltage. From DC link voltage, we have a another controller which control the traction motor. Okay, traction motor is controlled. So what is this input side? Input side is a utility friendly converter. That means if you see a rectifier, rectifier current is like this, a pulsating current. That means when the Ganga river starts from Haridwar, or I visited to Pauri, I generally go always to Pauri Garhwal for giving lecture in GB Pant College of Engineering, and NIT Srinagar I go. So while coming, I generally visit to Devaprayag. Devaprayag is where your Ganga start actually. So in Devaprayag, so beautiful water. I always go there and will sit where Lord Ramchandra came after killing Ravana. And that place, I will sit there sometime, chant Hare Krishna Mahamantra for for half an hour. And then I will drink Ganga water where they both mix there. And then I will come. So pure water, when the Ganga comes to Calcutta, Howrah, you see, because of this drainage, the Ganga water became polluted. Similarly, the power generation level is very beautiful power, but when it come to our so because we draw this non-sinusoidal current, that's why we get this. It is generating lot of harmonic. So nowadays the railway want that we should not generate any harmonic because it is very high level. So that is what it will impact on the grid structure. That is why we design a utility friendly. That means both voltage and current are sinusoidal and both are in phase. That means there is no reactive power, maximum power transfer, everything is maintained and controlled from two pieces. One pieces by using NI card, another by using D space. So we developed the controller. You can see here the complete unit you can see in this place. This is one PC which is control the input side. This is our auto transformer. We fed from auto transformer through this controller circuit to this unit, and this is our control circuit is going like this through these controls, and this DC link is connected to this link, and this is feeding this is feeding to this induction motor. So this way, this converter is controlled from here, and this converter is controlled from this PC. So this way, the complete unit was given, and this particular project was submitted to the Transportation Division of Bhopal BHEL, and because they were the authority for testing it, so this is a 75 kVA, and we developed this one. It can be extended for any amount of power. That is what it is, a very significant model, and there are a lot of bus bar testing, other things we also carried out. Anyway, there are a lot of, you can see that a beautiful result of speed change, other thing are given here. And there are speed change. These are the simulation and experimental result. You can see they both are exactly same way. It is matching each other. That is what the design of the converter. Okay. And anyway, these are the few hardware result I have shown you. And then this is the, you can see the both current are in phase and they are unity power factor. This means VI into cos phi is equal to 1, cos phi is 1, and VI in the power electronics is nothing but the displacement factor and distortion factor. And when you multiply, that is the power factor. So this is nearly unity power factor we maintain. And there are many, by using this three induction motor, we developed many three-wheelers also in our lab by the sponsored by National Mission for Power Electronics, Ministry of DT. And this we developed this three-wheeler by using developed induction motor in the railway. You can see that when you change the gear, you can see that there is a change in this according to one first gear, second gear, third gear, fourth gear. You can change. You can see that the complete design of this model was designed, and we have also designed few the low cost electric cycles, also very low cost, and some of the electric tricycles also we developed based on this BLDC motor drive, this one. And there are also some modular inverter for the electric car we have defined. So in that electric car, like a Tesla car, you have a below the battery structure. Similarly, we have a inverter, distributed inverter, where you can small module, even one inverter fails, you can put another inverter and it will work. And that is how this modular inverter setup we built for an electric four-wheeler drive. And this four-wheeler drive, you can see this one is, each one is a one module. This one module is one inverter structure, and this is the gate driver. And each module you can also take and put in the car in a different place so that it will not take lot of space. If you have a three-phase circuit, if it is not distributed, then it will, you need to make a space for accommodation, that one. And this one is so compact that it will only very like a UPS, you can fix anywhere here. So this is just, it is designed and by Junaid, and he just completed PhD. And this is our complete unit of that electric drive, you can see, for a electric car development, and everything is developed by our students. And this is that setup where you can, when you come, we generally test this one with dynamos, and when we test it, we find out with all of component we fed. You can see that two level inverter is feeding in each phase, and when we test it with lot of you can see that what is the, you can find out what is the noise, because in electric vehicle noise is one of the important thing, so need to be controlled. And noise is not controlled means you cannot sit inside the vehicle. So that is how we generally test after designing. We put in a dynamometer with different kinds of torque, and then we have now developed the multi-phase induction motor drive for specially for ship engines. So if you see here, this is a multi-phase drive, because multi-phase drive, there are a lot of advantages. Five-phase drive. That means if five-phase drive is there, if one phase is go out, then you can run at four phase. If for one phase more it go out, then you can run at three phase. For example, last time I was in the Hamilton for a lecture in New Zealand. So I went to New Plymouth, and from New Plymouth I came to Hamilton. In the Hamilton, they took me to Auckland. We came through via Bombay. There is a town called Bombay by. So when we came to Auckland, they took me to many shipyards. In that shipyard, I asked them that what kind of motor they use. They have to use four motors when they go out from the ship for the long ship. So they have four motors. If one motor burn, because if you go inside the sea, there are different kind of current wave. Sometimes there is a iceberg. So complete drive goes and struck to iceberg. That means you are carrying a heavy amount of water and somebody will come and you are carrying on your head, somebody will come and push you. So you will become unstable and fell down. Exactly this type of engine, when they go out, there is iceberg, so many things come in the way. So how they will control? Suddenly the motor start blowing actually. So that the propulsion motor sometimes burnt. So that is why I was discussing with them that when it burnt, then there are four set of motors. If one motor burnt, next motor they fit, then they run. But when you have a five phase, the same motor you can reduce. You can do that one. So this one we developed in the laboratory. You can see that complete unit, both converter, inverter. This is the five phase machine below the table, which is situated here. And this is the complete unit of five phase machine. And there are a few result of the torque. Whatever kind of torque you want, you can develop it. And this is our complete unit circuit here. And there are also, we test this one. So this test is for this five phase motor. You can operate till four phase, three phase. This is motor. You can see that this motor can operate up to, by using different switching technique, it can operate at three phase, even four phase, like that. So this is, we are feeding from 3 level, 2 level, and for both way we are. You can see that this motor, this inverter is perfectly working. This is so. These are few results, and we do also many experiments also, and micro wind and micro hydro turbines, and solar also. And this is our lab where I was telling you, first time we developed this is a matrix converter in the laboratory, and this is our all kind of hardware setup is there. This is a grid integrated three-phase inverter system, and this is I think this is Arvind, who is a student from CET, a PhD student of CET Bhubaneswar. He Jitendra, our PhD student, he was, and she is PLE is working on the charging infrastructure, charging of the electric vehicles. So uh, with this, I stop here. Thank you very much. And sorry for taking more time, 18 minutes, just because it is hardware. That's why I just took. If you have any
Uh,
comments or
Thank you so much, sir. So participants, if you want to put some questions or some queries regarding this, you can put your questions over here.
if they can send in my mail also, I have given.
Right, sir. Right.
Good evening, sir.
Good evening.
Good evening, ma'am.
Good evening, sir.
Myself, Prabhat Kaur Mahapatra from Indian Railway, working as a Deputy Chief Electrical Engineer in
Okay,
East Coast
sir.
Railway.
Okay, sir.
Sir,
Nice.
you shown the WC7 locomotive, WC6 locomotive, who are GTO based 6,000 horsepower.
Yes.
I worked with that locomotives from 91 till 2006, sir.
Okay.
I was sole in charge of that locomotives.
Oh,
That
okay.
6,000 horsepower, Sweden has had supplied 6 numbers. Hitachi had supplied 12 numbers. It was running in KK line, that is Kirundal to Kotawal Sad, Vijayanagar line. It is
Oh,
high
okay.
terrain, 3269 degree curvature, 160 to 100, 150 gradient. And it runs in Eastern Ghat. Hauls only mineral things, that iron ore from Belladel mines to Visakhapatnam port. So
Oh,
really,
okay.
it was a challenging system for Indian Railway.
Yes.
That for a haulage of this kind of 6,000 metric ton from Belladel to Visakhapatnam. Really, sir, I am very happy you involved in that locomotive. From
No,
that
actually,
locomotive,
I am a consultant to Chittaranjan electric locomotive.
yes, sir, you
In
told.
this, so I go regularly.
Sir,
In
from
yes,
that locomotives, then we developed the 3-phase IGBT based.
yes, yes.
We acquired. And our motto was to conserve main energy and with the same tractive effort. So
Yes.
we need more application in Indian railway system, sir. Sir, why you delivered that WG7 locomotive converter we used to convert a 25 kV input to 750 volt DC for utilization of coach service.
Yes.
You might have seen Rajdhani Express. Previously, we are using power car end of the train. Now, sir, we are taking power from engine, that is hotel load. What you told, sir, horizontal transformer. So there, sir, 500 kVA power converter is there, two numbers. We
Yes,
are
sir.
feeding to traction motor, AC traction motors, and also to coach service from hotel load. So
Yes.
really, Indian Railways is highly obliged this technology, and I hope you people will develop the nation in feed the Indian railway system, sir.
Thank
And many thanks to DRIEMS organization who invited me and gave opportunity to participate. And mainly, I am very highly obliged to Sushant Shetty, sir. Thank you, sir. Good evening. Goodbye. Jai Hind.
Thank you, sir.
Nice to meet
Thank,
you.
thank you so much, sir. It was indeed a learning session for all the participants present over here. And now it's time to felicitate our chief guest, Dr. Ranjan Kumar Behera, as a token of appreciation. Within the sir, please do accept it. Yes, sir. Yes.
Thank you, sir.
Sir, it's a token of appreciation from our side. So please do accept it. So we'll be
Thank you.
honored for this.
Thank you very much.
Thank you, sir. Thank you so much, sir.
Thank you. So thank you,
So,
everyone.
yes, sir. So please
Any
proceed.
other thing? Thank you, everyone, for joining. So, anyone want any help in this regard? I'm welcoming everyone. Even if students, many students, they come for some summer intern, they also develop the one student from Cochin. He came and last year he developed a last year the magnetic levitated train. One model he developed, and the same model he developed in Kochi, and he got the best the research award in the Cochin by Kerala government, that levitation train, okay, by using linear induction motor. So he designed very nicely. So he done same thing. Anybody can come, and we have lot of facilities. Thank you.
So, sir, so it's a request from our side if the participants could switch on their video so that we could have a virtual photograph over here. So sir, if you could take the photograph of the participants.
Hello.
Yes. Thank you, sir.
Hello. Hello, madam. Hello.
Yes, sir. Sir, please.
Madam, verify होने कौन सा कोई आता है कौन सी?
Sir, I'm not getting you, sir.
Hello, feedback from submit.
Sir,
Hello, ma'am. After the submit.
let me clear you.
Ma'am, after
yes,
ma'am.
Please, sir, proceed. You have some issues, so please proceed.
Actually, ma'am, after submitting that feedback form, there is a verification is required, and after going through the place with some word that required, that word is not getting.
Okay,
It
sir,
is not showing.
we'll get back to you with these issues in the WhatsApp group. We will again share that feedback form in the WhatsApp group. So kindly join over there, and we will definitely sort out your issue over there.
Okay, ma'am. Thank you. Thank you.
Yeah, thank you, sir. Thank you so much to the participants over here. So we are now at the end of today's webinar. I request Professor Sushant Kumar Sethi, co-convener to this webinar, to propose the vote of thanks. So please. Sushant Sethi, sir, are you there, sir? Yes. Sir, please proceed for the vote of thanks.
Hello, ma'am.
Yes, sir.
Madam, audible?
Yes, sir. Yes, sir. Yeah, you are now audible,
Okay,
sir.
okay. Okay, thank you. Thank you, ma'am. Jai Jagannath. A warm and graceful evening to one and all present over here. It is my privilege to propose the vote of thanks and acknowledge the contribution of those who have worked really hard to make this webinar happen. I, Professor Sushant Kumar Sethi, convener of the webinar DFPID 2K21, on behalf of Department of Electrical Engineering, EEE, and ENTC, DRIEMS Autonomous Engineering College, would like to extend my most sincere thanks to Lord Jagannath for his blessings and making today's event a resounding success. On behalf of the webinar committee, I extend my heartfelt thanks to our Honorable Chairman, Sri Pramod Chandra Rath, for encouraging us to arrange such events in a regular manner. Thank you, sir. I extend my gratefulness to our Group Chairman, Engineer Durga Prasad Rath, for encouraging our staff and students to conduct various activities and events in DREAMS around the year. Thank you, sir. I express my gratitude to our Director Administration, Sri Balram Kar sir, for his timely support to make our event a great success. Thank you, sir. I also express my heartfelt thanks to Director Academic and Coordination, Professor Lokanath Behera, Assistant Director Academic and Administration, Engineer Sudhanshu Sankar, respected Principal, DREAMS Autonomous Engineering College, Dr. Rajendra Kumar Das, for their constant endeavor in the organization of such successful event. Thank you. I sincerely thank our esteemed Chief Speaker, Resource Person, Dr. Ranjan Kumar Behera sir, Associate Professor, Department of Electrical Engineering, IIT Patna, for accepting our invitation and gracing this webinar as Chief Speaker, and for giving his valuable time from his busy schedule to enlighten us with his knowledge about the specified area. This session was really informative, and I hope it shall be helpful to all the participants in their research activities. I thank you, sir, for your valued contribution. With deep sense of gratitude, I would like to thank our Vice Principal and Principal in charge, Dr. Ranjan Samal, and Vice Principal Academic, Dr. Alok Ranjan Biswal, Dean Academic, Dr. Jivananda Mehna, Dean Student Welfare, Dr. Lina Patnaik, for their untiring support and best guidance to make this webinar a successful one. I would also like to extend a hearty thanks to all our professors, heads of the department, faculty members, staff members, PRO cell for the success of the webinar. I extend my thankfulness from the core of my heart to Dr. Behera Raju, NIT Warangal, Dr. Sharmili Das, IIT Roorkee, Dr. Abhik Chattopadhyay, IST Shibpur, Dr. Jai Krishna Maharana, Principal HIT, Dr. PK Pani, Dr. Prabhat Kumar Mohanty, Parala Maharaj Engineering College, Dr. Devabrata Das, Government College of Engineering, Kalahandi, Professor Dr. Ashwini Kumar Baliyar Singh, Parala Maharaj Engineering College, my teachers, Dr. Sanjeev Kumar Kaur, also some dignitaries, Dr. T. Suresh, and other esteemed professors from IITs, NITs for their participants in the webinar. My sincere thanks goes to the convener of webinar, Professor Pratap Chandra Pradhan, faculty coordinators, Professor Anurekha Nayak, Professor Satyaprakash Raut, and organizing committee members, Professor S.N. Samal, Professor Manas Ranjan Mahapatra, Professor Gokulananda Mishra for their efforts to make the event a successful one. My special thanks to our student coordinators, Saurabh, for his enormous effort and cooperation in preparing all the documents and for timely technical support. Last but not the least, a hearty thanks to each and every individual participants from different corners of our country. I hope this session will be helpful for all our future research activities. Once again, I thank you all for having contributed to the planning and organization of the webinar to make it a grand success. So we come to the conclusion of this event. Thank you one and all. Good night. Jai Jagannath.
Jai Jagannath, sir.
Thank
you, sir.
Thank you very much.
Thank you, sir. We'll end over here.
Sir.
I'm leaving now.
Okay.
Yes, sir. Thank you.
Thank you, sir. Thank you, sir.
Concluded this webinar.
Sir, we will end over here.
Yes, ma'am.
Okay.